Assalamualaikum and hi, my name is Putri Nomalkish binti Amraza at 70943. Today I would like to present about DC motor in printer. So firstly, we go to the introduction. So a DC motor is an electric machine that converts direct current electrical energy into mechanical energy by using a magnetic field produced by electromagnets or permanent magnets. It is well known for its high starting torque and simple speed control, making it suitable for propulsion and low power electric power system applications. However, DC motors have disadvantages such as bulky construction, low efficiency, and higher maintenance requirement due to brushes and commutators, which limit their use in high speed and maintenance-free applications. We go to the types of DC motor. The first type is separately excited DC motor. So a separately excited DC motor has its field winding powered by an external DC supply, independent of the armature. This allows very precise control of speed and torque by adjusting either the field current or the armature voltage. Increasing the field current strengthens the magnetic field and reduces speed, while decreasing the field current can increases the speed. Because of its accurate speed control, this motor is commonly used in precision applications such as laboratory equipment, speed governor, and control systems. Next, we go to the shunt wound DC motor. In a shunt wound DC motor, the field winding is connected in parallel with the armature. This results in a nearly constant field current, giving the motor good speed regulation even when the load changes. Speed control is usually achieved by adjusting a field rheostat, while lower speeds can be obtained by reducing armature voltage. So due to its stable speed characteristic, the shunt motor is widely used in applications such as ladders, fans, blowers, and machine tools. The third one is series wound DC motor. So in a series wound DC motor, the field winding and armature are connected in series, so the same current flows through both. As load increases, current increases, producing very high torque at low speed. However, at light or no load, the motor speed can become dangerously high. Because of its extremely high starting torque, the series motor is ideal for heavy-duty applications such as cranes, electric trains, winches, and automobile starter motors. The next type is compound wound DC motor. So a compound wound DC motor combines both series and shunt field windings in the cumulatively compounded motor. The two fields assist each other, providing a balance between good speed regulation and high starting torque. So its speed regulation is better than a series motor but not as good as a shunt motor, while its torque is higher than a shunt motor but lower than a series motor. So this makes it suitable for applications such as rolling mills, presses, shears, and machine subject to sudden or shock loads. So the last types that we know is permanent magnet DC motor or PMDC. So a permanent magnet DC motor uses a permanent magnet instead of field windings to create the magnetic field. This makes the motor simpler, smaller, and more efficient with reduced cost and maintenance. Speed control is achieved by varying the armature voltage, usually using electronic controller. Permanent magnet DC motor are widely used in small devices such as toys, mobile industrial equipment, and they provide nearly linear torque over their normal operating range.
My name is Nur Amira, S72008. My part is operation of DC motor in printer. Printer use DC machine to convert electrical energy into mechanical energy. Energy conversion occurs through electromagnetic interaction between emitter and field. 3.1 is energy flow in printer system. AC main power is converted to regulate DC by power supply unit. DC energy is distributed to motors control circuit and thermal unit. Electrical energy is converted into mechanical energy for paper feed and printer heat movement. Thermal energy for toner fusing in layer printer. Power management reduce energy consumption during standby mode. As you can see, figure 3.1.2 show 3D printing process to energy device. In this part, we focus energy conversion device, thermoelectric, piezoelectric, and triboelectric nanogenerator. Brushless DC motor in a printer operate using mechanical interaction between stator and current carrying armature. Mechanical communication using brushes provide continuous rotation. Commonly used for paper feed, simple motion control. In a figure 3.2.1, an actual brush DC motor has a external coil winding on armature. So, we move to 3.3 brushless DC motor BLDC in printer. Use electronic commutation instead of brushes, stator winding and permanent magnet rotor generate torque. Control using PWM closed loop controller. Advantage: high efficiency, low noise and long lifespan. 3.4 Torque speed characteristic in printing operation. Torque speed behavior affect print quality and speed stability. Long variation require effective feedback control system. Advanced controller maintain constant speed under changing load. Proper torque control ensure accurate and smooth printing. Figure 3.4.1 Torque speed curve of BLDC motor with printing application illustrate. Speed control and drive circuit. Speed controller regulate motor speed and torque using feedback. H-bridge and chopper drive enable bidirectional motor control. BLDC drive use sensorless of sensor-based electronic commutation.
Now I will explain the applications related to printers in DC motors. In this section, the applications are divided into two parts. The first part focuses on the applications of DC motors within printer systems, while the second part discusses the applications of printers in various sectors. DC motors are important components in printers because they provide the mechanical motion required for printing operations. One of the main applications of DC motors in printers is the paper feed mechanisms. The motor drives the rollers to pull paper from the tray and move it smoothly through the printer. Proper control of the motor speed helps to prevent paper jams and ensures correct paper alignment. DC motors are also used to move the print head, especially in inkjet printers. Smooth and controlled motor movement allows accurate positioning of the print head, which is necessary to produce clear text and high-quality image. In addition, DC motors are also used in ink and toner handling systems, as well as in maintenance functions such as print head cleaning and paper ejection. These applications show that DC motors play a key role in ensuring reliable and efficient printer operation. For this section, printers are widely used in many areas of daily life and industry. In educational institutions, printers are used to print lecture notes, assignments, examination papers, and certificates. In office and business, printers are essential for producing reports, letters, invoices, and official documents. Printers are also important in healthcare for printing medical reports, prescriptions, and patient records. In addition, banks and retail sectors use printers for transaction receipts and financial records. Overall, printers support effective communication, documentation, and record keeping in various sectors. In conclusion, DC motors are necessary for printer operation because they provide consistent and controlled mechanical motion. Their smooth rotation, simple speed control, and cost-effective performance make them ideal for a range of printer activities such as paper feeding and print head movement. Although DC motors have limitations, developments in motor control technology and the use of brushless DC motors have significantly increased printer efficiency and endurance. At the same time, printers serve a wide range of applications in education, business, healthcare, government, and industry, supporting effective communication and proper documentation. Overall, the integration of DC motors in printer system plays a crucial role in enhancing printer performance and reliability, making them indispensable components in modern printing technology. That's all from me. Thank you.